Brown Dog Gadgets live.
All right.
Hey, I'm Josh from Brown Dog Gadgets, not actively sharing things. Here, Pete, you can share these things to some groups. Yeah. We're I always like share things on Facebook while doing this, and I totally forgot to do that. So we're gonna have Pete just randomly share these to a bunch of different groups on my phone. To spam all these other Facebook groups. So hey, I'm Josh from Brown Dog Gadgets. Clearly not spamming Facebook groups. So if you
press all of them.
just go through and do a lot of them. No, probably not the ones that clearly are not education related. But so we're here. It's was it Wednesday? It's Wednesday.
Thursday.
Oh shoot, it's Thursday.
Yeah.
I'm Josh. I don't know what day of the week it is.
July 2nd.
Small child at home. I don't know what day of the week it is usually. But so we're here. We're going to be doing a fun Lego project using our Crazy Circus components. These are our, wow, does not work on green screen. Let me try a different piece here. There we go. These are our Lego compatible circuit boards that we have that pop onto Lego and that are connected with each other thanks to our wonderful maker tape, our nylon conductive tape. So you can build fun circuits. I can't grab that screen. All the Lego base plates are green.
Hold on. Watch this.
There we go. We can do fun things on Lego, and we can make circuit boards on Lego basically. So that's what we're going to be doing today. We're going to be using a cool potentiometer piece that we've just started producing this year, as well as some NeoPixels, which are individually addressable RGB LEDs, which means you can control a bunch of them with just three pins, data and power and ground. I'm going to show you how you can manipulate the two of those together, how easy it is to build this, and how you can add this to a bunch of different Lego-based projects or conductive sewing projects, because these guys also work really well with conductive sewing. And every now and then I just build these projects on paper because it's easy just to run maker tape from our boards or from each other onto paper or another surface that's flat. Yeah, conductor thread works really well, just it's annoying as heck to sew. But that's conductor thread for you. So we're going to give this a whirl. I'm going to zoom in a bit here because I don't want to be this far away. And a little focus action there. So, and by the way, if you're watching today and like what you see, please follow us on one of these many social media spots. Ta-da! Instagram, Facebook. I should go like this. Instagram, Facebook, Twitter, Facebook, wherever you're watching. If you're watching whatever place you're watching this, please follow us because we do try to put out live streaming like 3-4 days a week typically, and we have guests that come on. We show cool projects. Everything we do is open source. You can find these directions and resources on our website. So even if you don't want to use our Crazy Circus parts, you grab an Arduino, some NeoPixels, a potentiometer, and a breadboard and build this yourself using our code. It's just we have it in this format right here. If you hear a doorbell in the background, that's because Andy, our curriculum writer, just came in from his car. So thanks,
welcome
Andy.
back.
Welcome back, Andy, into the office. So anyway, let's get down to building. So yay. First and foremost, this board here is our Crazy Circus robotics board. We have a couple different programming boards, including a microbit board we're coming out with later this year. Let me make sure my audio is going well, because we've been having audio issues, apparently, that no one's told us about. I blame you.
If you hear strange audio, please leave a comment.
Yeah, if you hear any weird echoing or weird things happening, like we don't typically watch these afterwards, let us know. Comment. Do something, people who might or might not be watching. But anyway, so any Arduino will work, microbit will work in this kind of process. Our code is set up for just a standard Arduino. And we have this nice little diagram here showing how everything hooks together, because that's Pete. And Pete's going to be posting this up on the website in a bit. You can also find, by the way, this is just very simple microbit related code that we're using. Potentiometer control and microbit. NeoPixel. There we go. NeoPixel. So you can see a ton of like examples of this all over the internet, and because NeoPixels are really cool. I actually made, if you go through our Instagram account and some of our social media and you keep going down back into like last November, we made a 6x6 matrix of these on a big Lego sheet for a teaching conference, and just had some simple animation running. And you can it's just one data pin to connect them all and then power. But NeoPixels are great. They're way better to use and easier to use than an RGB LED, especially if you want to use multiple ones of them. So we're going to get rid of a lot of these guys. We only need one today, though we could use more. And this is our simple diagram. Like all of our Crazy Circus parts, we have our ground pin is always white. Any ground is white. We have a 5-volt pin we'll be using and a data pin. So data, ground, 5 volt. Now we could also say run 5 volt around this way if we wanted to. Same thing with these other pins. There's a lot of ways of doing it. It doesn't matter how you get there. And there's a lot of ways you could say put this thing together to make life easier for yourself as well. But just depends on what you want to do. And so we're going to...
Depends on how much tape you want to use, I guess, too.
Well, the nice thing about our tape is, now we typically go over the top of the studs, but you can also go between the studs, which is a really easy way of, say, jumping a line like we have here.
It's like your two-layer circuit, as it were.
Exactly.
Yeah.
I've seen people go the crazy route of just like building up like a little Lego bridge to go up and over, which seemed like a lot more work, use a lot more tape. But it's really easy just to lay a line down in the middle for that. So we're going to start with doing this. Now, we've pre-programmed this board, so there's nothing to nothing to program today. But Pete, is that code up on our website already?
It will be.
That's a good answer. It will be. So we're going to start first and foremost by building a little platform for our circuit board to hang out on, because the middle of our board doesn't have any Lego holes in it. So we can't just lay it directly on here, and we want to use both sides of the board, so we can't just put it on the edge. I like doing edge projects on the edge, so it just lays flat off the side. And we're going to need some on both sides, so I'm just going to make sure I space things out correctly. And we're here, we're going to go one here. Typically, if you're going to do this, you're going to want to use like a 1x6 plate or something. These are just the things we had closest around when we started grabbing stuff for the live stream today. So
I wanted to color coordinate the pieces, so that's what I found.
Oh, Pete, you are an amazing color coordinating man.
I can see in color.
It's true, he can. Some of us can't see all the way in color. So there we go. We just built a little platform up here. We're not going to use all of these Lego pieces galore because we don't need to. Yeah, not a problem at all. So we're going to take this guy off right now, seeing that we know where our corners are, just for reference point. And that should make life pretty easy. And then we're going to first go and do the hard one first, which is the NeoPixel. So we're going to put the NeoPixel here on the edge just so we can kind of get a good view of it. On here, like spacing things out a little bit extra. We're going to grab our maker tape.
I see a little DI and a DO on that NeoPixel. What's that all about?
Well, one stands for digital input. The other one stands for donut.
No, that's not. I don't think that's right.
Oh, no. NeoPixels have a digital in and a digital out. So if you're going to string a bunch of them together, you want to go in, out, in, out, in, out. Whereas you can daisy chain. So if we actually flip over, hey, Pete, let's go to the close-up camera.
Close-up.
So our NeoPixel here, we'll get one here, we'll turn another one upside down so you can see the backside. So if you look on these two boards right here, the middle section, they're not connected together. Oh, thanks, Pete.
Sure.
You can see here, the middle two holes are not connected together, but the outside two are there, and the outside two are actually connected there as well. And that's because it doesn't matter for power, we're just fine. Although for the positive, we do have a little capacitor here. Yay. But they're connected together, so it doesn't really matter how you hook them together because it's just, positive and ground. But it is a digital in, digital out. So if you have one backwards, a NeoPixel backwards, which you'd obviously know if you had it flipped because it wouldn't make sense with the other ones. The ground and positive wouldn't line up. But that would make a difference. It wouldn't signal wouldn't go through. It wouldn't daisy chain through. So there we go. Close-up camera. So, yeah, that's what you do with a NeoPixel. NeoPixels are great. They've been popularized by Adafruit. Has done a nice job. They, what's the official term? We actually have the official part number on here.
It's a WS.
No, this is an SK6812 Mini.
Yeah.
There's actually even a smaller
right,
version than this. This is the medium-sized one now. There's a smaller one. That's the one we could get fit in between our Lego studs here. The regular-sized one didn't. We tried a lot. But I think there's even a smaller one now. But there's a couple different versions out there. They all run the same way, but it's a much different approach than using your standard RGB LED.
And Josh, as I understand it, it's basically it is sort of an RGB LED, but it's got a controller chip in it. Is that right?
Yes, there's actually like a little black spot. It's hard to see, but if you find any close-up photos, there's a little black speck in there. That's the controller chip.
Right.
That's just handling the RGB nature of it. So you don't have to like have tons of stuff. Because typically with an RGB LED, we need red, green, blue, and then a common output, ground or common positive.
Yeah, because you're controlling the RGB LED. You're controlling basically three different LEDs that just color mix, right?
Yeah. So if I was doing this with a standard RGB, which is the part we actually sell, I would need 3 lines for one, 3 lines for another, 3 lines for another. So it's a lot of digital pins you're using.
Yeah.
I'd quickly run out of digital pins on my Arduino very quickly, or need additional hardware to control it. With the NeoPixel, I just need one signal to just chain all these together, and I can say green, blue, cyan, white. You can tell in the chain, like the 5th one, the chain do this. The 6th one, the chain do that.
So in the code, you need to specify how many are in your chain, and then you send the commands, sort of down the chain, as it were.
It's true.
Yeah.
And it works pretty darn well.
Yeah,
and it's
great.
simple. There's a lot of good example codes since they're out there universally. You'll see, I think from Adafruit, one of the more popular ones, it's a donut with LEDs around it, which is really nice. So people do a lot of like the Iron Man chess piece or other fun displays. But I was just like, it's a great way to interact with, say, sensors, like a distance sensor or a temperature sensor or something, or a sound sensor, because it's so easy just to plug in your sensor, and it takes away all that extra wiring work, and the real work's in the code. But they're nice libraries, and it's fairly straightforward of how to use them. Now we're going to be using a potentiometer to control that, and I should probably get around to making this now instead of chit-chatting. So I'm gonna make this thing. We're just gonna go like so. Right.
Now you're going to be using the 1/8" maker tape. I
Yes,
believe.
indeed. Our 1/8" maker tape, because that works the best with this, and I'm gonna try and line up my digital in with my 5 volt, my number was it D9 pin, because that's what
D9, yes.
D9, bingo. But before I'm gonna do that, I'm actually going to lay down my my little between the hole piece right here, and I'm gonna be really, since we're on camera, I don't want to spend all day doing this. I'm just gonna make it really kind of sloppy, so I can push this down. Now I have a line here, and I'm gonna come over and up to my corner piece right there.
So that's your ground.
My ground. Yep. Because I want to, there's a couple different ways you could run it, say, around. My ground around. Yeah. So, sorry, this corner piece right here. No.
That one.
Yeah.
That's the one.
Yeah, sorry, the other one's, that's 5 volt is up here.
Yes.
Oh, all right, I know what I'm doing.
Yeah. Yep.
Watch as man
There we go.
flails around. All right,
Yep.
we're good.
There you
I'll just go crazy. All right, so we're just going to go here. Since our maker tape is conductive on top and bottom, I can just have it overlap and touch this piece down here.
Is there a technique for putting it on that last peg where the board sits on top of?
So you want to give a little slack on that, because when the board does sit down on top, it's going to pressure fit a bit.
Yeah.
And so you want to kind of go all the way to the edge, but not too far over. Like in this situation, I have the 5 volt's going to be right here, so I don't want to go super far, but as long as you're not touching. I mean, it's fairly obvious, especially with these bigger projects, when things are not behaving properly. So we're going to go like this, and I just always like to, if I like to, take my fingernail and just press down a little bit there, so a little bit of indentation, a little bit of give, so to speak. But since it's conductive on top and bottom, if I screw up too badly, I can just add more tape.
Yep.
And if you're going to be really quick and lazy about this, it works just fine to run the tape over the top of some of the holes. Now, specifically for like the Arduino, because there's nothing around it. There's no little pieces, no little other components around. Whereas with the NeoPixel, you've got resistors and capacitors on there as well. You probably don't want to be running into those. That would be bad. But you can just run it over the top. I do that when I do paper circuitry projects.
Oh yeah.
A lot, because it makes life simple. So there you go. Now I got my positive here. Yay. It's connected positive. My negative is down. Let's see.
And there's an air gap, sort of, right?
Yep, there's an air gap.
Yep,
so
yep.
these guys definitely don't. There's definitely clearance. There's a bit of clearance. I'm going to do the same thing over on this guy right here. Just lay a bit of tape down. It's not going to be the prettiest thing in the world, but it's going to work just fine. So we're going to run from here down to that other spot. Now, when I make a permanent project, something I take to trade shows and events, and actually, Pete, if you would actually grab it, it's up there on the shelf.
Oh, sure.
On underneath the microbit or on top of the microbit example, we have it there. What I tend to do is I do this piece here that goes from the part down first, thanks. And then I lay this rail, this common rail, down on top of them all. That way I know they're nice securely down. Like in this situation here, I did the negative rail from the piece down, and then put it over the top so I knew there was a good connection all the way through. And this is a much bigger NeoPixel example that I made a while back with 3 potentiometer pieces that we had on there and a bunch of NeoPixel. I took this again to a teaching conference a while back, but it just, each of these controlled, I think, color, speed, and brightness. It'd just be like a little back and forth chain that was happening. So that's the same kind of approach, just different code. I think it's just example code I found on the internet. But see, we're just going to do this right there, connection, and then the last thing to do is go from the digital in to the pin 9. And that one I actually do have to be exact on because I don't want to overdo it and go too far. And so it's pretty quick and easy, especially if you've gotten a little bit of a hang of it. So I'm just going to trim. Ta-da. And I should be able to I went too far in this guy. Oh well. That's right. Doesn't matter because it's all the same pin. Yeah, you don't have to. I clearly was paying attention well.
Well, you are talking to the audience of, I mean, up to, who knows, 5 people maybe. And
up to 5 people.
And also building, so, I think everyone, again, it's July, 2nd, so a lot of people are probably headed out of town for the big celebration this weekend, I assume.
There we go. So now we have this connected. I've got this here. You might want to readjust any of your little pieces, and then la-di-da.
Yeah.
There.
Nice. And it didn't light up, though.
No, because we haven't added power, and we haven't added our... Oops, I had this backwards compared to the project.
There we go.
Yeah, whatever. We have to do the same thing over here, but this should be easier because there's no overlapping and whatnot. So we're going to take our potentiometer, drop it down. And potentiometers are great. It's a variable resistor. It's got a little physical aspect to it as it moves along that resistor. It goes from 0 to, I believe these are 10,000. I should know. I purchased them. 10,000 ohm. And so we're going to...
Which with your Arduino,
A4.
will be a value between 0 and 1023.
There you go.
1023.
So we're going from, is it A4 on this one, I guess it is?
Yes, it is. Yeah.
And so we're just going for A4 out to the center, positive, and then ground straight up. That's what we're doing it this way. Try to keep as many straight lines as possible just for convenience sake. So ground to ground, 5 to... from positive to 5 volt, and that's why we're using A4 there, just to kind of get a little extra clearance and around, and that just makes things really easy if we can just plan things out. I always say with these things, these guys are never tough to build. It just helps if you spend a moment and plan things out, and then you end up with a situation that is a little easier on you in the long run. Like this guy, another guy that I built ages ago, I sat down like, okay, how can I do this? What's my planning? Which you'll be doing anyway in any large-scale circuit project. You'd be planning things out plenty ahead of time, or using a program like KiCad to design things up, make your circuit, design things up, and then lay out your pieces.
There's no auto router yet for crazy circuits, But typically if you're doing a breadboard or a PCB, a printed circuit board, you've got to do some design work figuring out, where everything's going to go to make it fit. So same thing here.
I'm just going to do this. And much like our NeoPixel, all of the through holes on here, these little white lines on there connecting. These 2 are connected, those middle 2 are connected, and the far 2 are connected. You can easily see it on the bottom with the copper on there. So you can tell which ones are connected. Yay. And then to do maybe like this. So we just got to hook up our 5 volt. Now, Pete, why are we using 5 volt?
Why are we using... That's what the Arduino runs.
That's what the Arduino runs, although we do have a 3.3 volt output on here as well.
Yes.
So now I'm just going to do a nice little right angle turn. Right angle turn.
So, the way a potentiometer works is you're basically sending 5 volts through it. So your plus 5 volts goes through and flows around through the ground. And then as you turn the potentiometer, it's a variable resistor. So that third pin, the signal going into our analog pin, is going to change depending on how you turn it.
And there we go. We're just going to make sure I put this in the right orientation.
Yes.
And I did not have enough slack there, but whatever. Ta-da.
Wow.
And there we go. Little Josh.
Well done.
Facing the way.
There we go.
Now, to make life simple, we're just going to use this wonderful Brown Dog Gadgets labeled power bank. You can see it's how old it is. It's from our Kickstarter campaign, like in 2011. Or is it 2012? I forget.
I feel like I have about 10 of those at home.
They're good.
Yeah, they're
And
great.
there you go. It's going to turn on. There is our NeoPixel. We can change the color by turning the potentiometer.
So it should go through red, green, and blue, and then kind of fade up on each one as you turn. You can kind of set
Hey,
the...
Pete, do you want to go close-up camera so people can see how cool the
Close-up
NeoPixel
camera.
is?
Let's do
Because
this.
why do we have a close-up camera if no one's doing close-upness with
Let's,
it?
you know, let's try this too. Maybe we can
Wow.
sort of help it all. You can kind of see it.
Anyway,
Yeah.
so
That's
that's
much better in person, I gotta tell you.
they do. They get really bright.
Yeah.
Okay, enough of that close-up camera crud. NeoPixels are great. They do get really, really, really bright, like really bright, and they can draw a lot of power when you have a ton of them together. Because each one essentially is 3 LEDs, so about 30 milliamps per setup.
Josh, let's try. Do me a favor here. Let's do this. Let's put this. Here, put this
Put a
over
diffuser
the
over the top?
and see if you kind of get a different. See how it looks on camera. I don't know.
Looks okay.
Sometimes that helps a little.
So we
Yeah,
have
it
the
looks a little better.
the monitor here. Ooh. But yeah, they can get really, really darn bright.
Yeah.
And they can run really hot. We have a ton of them together. But this is basically the maker movement has latched onto these heavily. But thanks again to Adafruit doing a nice job of promoting these and giving the name NeoPixel. I don't know if it's trademarked or not. Probably.
I mean, WSB8212 also sounds cool, but yeah, NeoPixel is.
It's just not so catchy on the old ears.
We've got a note here from MakerBlock. Says there's 4 people watching, so that's even though
Oh,
it's
yay.
1.
Well, you
It's
know what,
really
MakerBlock, you
4.
make us feel better that we're just not talking to the screen in front of me here and the Canon camera in front of me.
Yeah.
Yay. Oh, there's somebody else. It's
Andy said something about Wayne's World. I don't know what.
Party on, Andy.
Party.
A curriculum writer,
Go
Andy, is just
searching.
monitoring our audio to make sure it's not weird again. But no, definitely try NeoPixels from anybody. This is just an easy way of adding it to Lego because one of our projects we're going to do here for we're going to do a Kickstarter campaign for a microbit board. Yay. One of the projects we have kicking around, like what should we do for showing off projects, is using some of these to add some animation type effects to a Legotron thing. We have one of the little Legotron sets with the little light cycles on there. And we're going to add a little bit of motion and add some light so that this little LEDs that go just across, like a couple little LEDs across. So it gives the impression like it's moving.
Yeah.
Like do, and just different colors though, because then we can use, say 4 or 6 LEDs and then have it just switch up colors like blue.
Yeah.
Red. And just a nice, easy effect. Much easier wiring. It would just be one data pin then to all 4 or 6 of those.
Mm-hmm.
Super easy to do, but definitely worth doing. I would not recommend doing a gigantic matrix on Lego as I sat there cutting little tiny strips of tape all night long. Found out the length of it was between each one, just cut like a ton of them because that was it's like 90 little strips of tape plus on that.
That's a lot.
Was annoying.
tape.
It was
You
just
should get like a tape cutting machine. Just cut it for you.
well, we have a tape cutting machine, but it doesn't
Oh.
work with our 1/8-inch tape because it's too thin. It jams up the machine.
No.
We use it to cut strips of our 1/4-inch stuff for
Gotcha.
workshops and a few of the kits we sell.
Okay.
Just that works well because it's a fabric tape.
Mm-hmm.
But yeah, NeoPixels are easy. Pete, is this up on our website yet?
No.
No, it's not. It will be.
No, because there's like 20 of these different lessons. So
Oh, Pete's
we-
putting up a
we'll
bunch of different lessons and activities in our Arduino like curriculum setup. Just
this is
some-
a sneak peek of what will be.
oh,
coming.
there we go. Sneak peek.
Yeah, sneak peek.
Clay
I'm
was
a
paying
sneak
attention
peek.
before the live stream started on what's going on. It's spreadsheets all day.
All right.
But no, this is pretty quick and easy to do, adding NeoPixels. And I do like these for lighting effects, putting some clear LEDs over the top of them, LEDs, well, clear Legos over the top,
clear
or
Lego.
translucent Legos. Looks really nice when you can change the color behind it, get some nice throbbing effects or easy effects. It's a simple way of doing things. Even more cool tool. If you want to, grab like a Arduino could even be overkill for a project like this. Like an AT Tiny 8.5 even.
You could use that.
Like a super cheap little tiny AT Tiny 8.5 like we have right here.
Yeah.
But this is pre-programmed from us. But say if you were to program one of these yourselves, just data output from this, along with power from some power source.
Mm-hmm.
And you could have this little guy right here control like
You got it.
400 NeoPixels or however many you can have in a chain. I don't know.
It depends on how much current. So that's the issue is as you increase NeoPixels, you need more current.
Well, and actually what you just, I would end up doing is what I did with the matrix I did.
Mm-hmm.
Half it was powered from one place, half from another. Like I had two different battery packs
Right. Yes.
just to make it last longer in a trade show.
Yeah.
Half had positive and negative from one battery pack, one had it from another, and then I knew I was good. They were nice and bright the entire show. And then I had a power bank powering the Arduino because you don't want to run that much current through your Arduino, you'll burn it out. And it made life really easy. But it's the same data pin. That's fine. But cool beans. Well, that's it. If anybody has any NeoPixel questions, email us. But we have these on our website. We're going to start putting them in kits very soon. And we'll have these definitely in our microbit kit we'll be putting out this fall, and our classroom sets. Both of these guys in that bigger microbit set we'll be having later with our microbit board. Which is fun. So anyway, we're going to get out of here. BrownDogGadgets.com. Follow us,
check it
please.
out. Definitely.
If you like us, if you don't like us, also follow us. The Howard Stern Effect.
Exactly.
Don't like us, just watch like, God, those guys are on again.
Oh no.
Jerks.
Okay.
But we're gonna get out of here.
So we're not here tomorrow, right?
No,
We're
I'll be
back
here doing
next week.
spreadsheets all day.
Oh.
That's why no one
What?
bothered me. I'm doing spreadsheets tomorrow.
Okay.
Yeah, literally
No
that's
streaming tomorrow.
That's
We'll be
but
back
no
next
streaming, just
week.
me and the dog.
All right, we'll have amazing projects next week.
We will.
Share.
We'll be doing some fun stuff and showing off
Alright.
more projects and maybe going over some curriculum and other things and showing off how awesome green screens are with Legos. Because we have green board on green Lego.
Those translucent Legos you were talking about.
Yeah, translucent Legos.
Yeah,
it's
there
even
you
it
go.
makes me invisible. The invisible
Transparent, yeah.
Josh.
Wow.
But so
Okay.
this is why I like the blue base plate. Looks
Couldn't
better.
find a blue one.
Although you still got
Sorry.
the green circle.
Kinda.
board. Get out of here. But anyway, thanks for watching. We'll be back next
Alright.
week.
Yeah.
Take care. NeoPixels are cool.
All
Bye.
right. All right.
Thanks for watching. Please visit browndoggadgets.com for parts, projects, and curriculum. Follow us on social media at browndoggadgets. Check out our live streams at Facebook, YouTube, and Twitch. We'll see you next time.